Have you ever just stopped and looked at the world around you? I mean, really looked. The chair you're in, the device you're watching this on, pretty much everything. It's all made of, well, stuff. But where does all this stuff, with its amazing colors and textures and abilities, actually come from? Well, that's a wild story, and it all starts with something as simple as color. Just look at this. These deep blues, these brilliant yellows. This is the kind of color we're completely used to today. It's in our cars, our houses, everywhere. We see it so much, we just take it for granted. But honestly, this kind of vibrancy is a really, really recent invention. So that gets you thinking, right? If you wanted to make a color this bright, this permanent, say a few thousand years ago, how would you even do it? And how on earth did we get from that to this? It's a story about solving one of humanity's oldest challenges: how to make beautiful things that actually last. To really get our modern world of materials, we've got to rewind the clock. We have to go back to a time when our only option for making stuff was, well, whatever we could dig out of the ground or pick from a plant. I mean, check out the difference here. On the one hand, you've got this ancient art made from natural pigments, crushed up rocks and plants. It's amazing for sure, but it's faded. And on the other hand, a modern kayak with a yellow so bright and tough it basically laughs at the sun. This isn't just a small step forward, it's a total revolution. The thing is, those early natural pigments had some serious issues. They'd fade when exposed to sunlight and air. A lot of them were actually pretty toxic to handle. And if you wanted the really good colors, they were often super rare and incredibly expensive. We just needed a better, more reliable way to color our world. And the solution didn't come from just finding some new, better rocks to grind up. No, it came from understanding the basic rules of how matter itself works. You see, to build better stuff, we had to learn how to speak the language of materials. And that language is all about something called properties. It's not just about what a material is, it's about what it can do. So first up, you've got physical properties. These are the things you can see or measure without actually destroying the material. Is it red? Is it heavy for its size? Is it hard like a rock or soft like a pillow? That's its physical identity card, basically. But then you've got chemical properties. And this is where things get really cool. This is all about how a material acts when it gets into a chemical reaction. Will it catch on fire? Will it rust? This is all about its potential to completely transform into something new. Think about it like this. The only way to prove a piece of paper is flammable is, well, to burn it. And in the process, you change it forever. To know if iron will rust, you have to let it hang out with oxygen and watch it transform into a totally different substance. That's the power and the secret of chemical properties. So why does any of this matter? Because once you understand this language of properties, you're not just using materials anymore. You're a designer. You can pick the perfect material for any job, whether you're building a bridge or, a kayak. Okay, let's put this into practice. Let's go back to that bright yellow kayak. It is the perfect case study for this whole idea. All right, here it is again. Now, this thing didn't just appear out of nowhere. Every single curve, every feature, and especially the material it's made from, was chosen for a very, very specific reason. So let's put on our engineer hats for a second. If you were designing this boat from scratch, what would be on your material wish list? What are the absolute must-haves? Well, here's the cheat sheet. It's got to be waterproof, obviously, so you don't sink. It needs to be tough enough to handle bumping into rocks, but also flexible enough that it doesn't just shatter on impact. And it needs to have a low density, which is just a fancy way of saying it needs to be light enough for you to actually carry it. And here is the absolute key to all of this. You are not going to find a piece of wood or rock out in nature that just happens to have all of these properties perfectly balanced. So, we make it. These perfect combinations of properties are engineered into what we call synthetic materials. But that word synthetic can be a little bit misleading. It kind of makes us think of something totally fake, something cooked up in a lab out of thin air. But the truth is actually way more connected to the real world. So if we don't just find them in nature, and we're not just waving a magic wand and making them appear, where do they start? Where do they come from? Okay, get ready for this, because it's pretty wild. This bright, solid, perfectly engineered kayak, it comes from this: black, gooey, liquid crude oil. The plastic in that boat is a direct descendant of a natural resource we pull out of the earth. And this right here brings us to the single most important lesson of this entire story. It's a fundamental truth about our world. All synthetic materials are originally derived from natural materials. Everything we make starts with something we find. The whole process is kind of like a form of modern alchemy. We start with a natural resource, then we use some clever chemistry to break it down and rearrange its basic structure. And out of that, we engineer a totally new synthetic material that has the exact properties we were hoping for. So when you look around at the world now, you can start to see this incredible story playing out absolutely everywhere. It's really not about natural versus synthetic as if they're on opposite teams. It's more like a partnership. It's the long, continuous story of us learning the secret language of nature and then using that knowledge to rewrite the rulebook, to transform the raw materials of our planet into solutions for our everyday lives. From those faded pigments on a cave wall all the way to the vibrant plastic of a kayak, we have come an incredibly long way. We've gotten really good at taking nature's ingredients and creating brand new recipes to build our world. It kind of makes you wonder, doesn't it? What problems are we trying to solve right now, and what amazing new materials are we on the verge of inventing, all by transforming the natural world in ways we can't even imagine yet?